My roommate Tony is trying to stay healthy, track his meals, and keep up with her fitness goals. But like most of us, he struggles. How many calories were in a daily meal? Did his morning walk burn enough to enjoy dessert tonight? Tracking it all feels overwhelming. Tony isn't alone. Over 80% of people underestimate their calorie intake, and fitness tracking apps often feel like more work than they're worth. That's where we come in. In today's world, food isn't just nourishment, it's a source of anxiety for many. Social media bombards us with perfect plates, diet trends, and endless calorie talk. For some, tracking meals and exercise feels more like a chore than a tool for health. This calorie anxiety has become a part of daily life. We're so focused on numbers that we lose sight of what really matters, living a balanced, healthy life without the stress.
And I have used different apps to track my calories because I've been always pay attention to my nutrition intakes. So I think it will be a great app, and with a feature that you can take picture and just give you an estimation of your calorie, I think it's a really cool feature to have on the app.
That's why we created Project Calbalance to take the anxiety out of eating and exercising. Our app helps you track your calories and fitness goals effortlessly.
Okay, hello everyone. There's group 6, and here's our final project. This is called Balance. And you can see that the obesity rate in the United States have been climbing at an alarming rate despite growing awareness of fitness and healthy eating. And you can see that a study revealed that many Americans are unaware of their daily calorie needs, with a significant number of over-consuming high-calorie foods containing refined grains, added sugars, and fats. And even though with this rising obesity problem, the control and management of our weight is still an overwhelming problem for most of us. But with the advancement of wearable technology, we can better modify and manage our weights. And also, you can see that the market of weight management and weight loss apps is still in a growing trend. So the weight management problem is still a big kick for us.
So for the purpose of idea, we want to simplify the calorie tracking for individuals who find that it's a hassle or challenging. So we want to develop the friendly platform to who want to calculate the daily calorie intake and consumption. And we also assess users to manage the diet and exercise track. So let me show you how our programs works. So we first put the user personal information into our database because different height and weight have different consumption. So we want to make sure this is accurate. So for the calorie intake, it's calculated using inputs such as food, pictures, and in our system we use image recognition and database matching to estimate the calorie for each type of food, and also with some drinks. So on consumption side, we use data from wearable heart rate sensor to measure physical activity levels. The system also adapts to different activity types. It can be lifting or running, even the commuting steps. So calculate the calorie consumption based on change in the heart rate. So we have a total calorie burn in the day, and if you burn more calories than your intake, you're gonna successfully lose your weight.
And now is the whole architecture for our system. Here on the left side is the endpoint, which is the IoT device, a mobile phone and pulse sensor. And on the right side is a service that is deployed remotely on AWS. And also, the mobile phone serves as a front end to display the results. And we use Flask to build a backend server. And now the process is like this. The IoT sensor will collect the data and send the data to ThinkSport, and then the backend will analyze the data from ThinkSport and do the calculation on it, and then send back the calculation data back to front end to display. And here's our implementation. the dashboard. On the left side shows the weekly calorie balance and daily intake and consumption, and on the right side is the user's daily commuting route. Here are some current application that is in the market, and we do the comparison between them, and here's our feature. So first, we use AI-powered image recognition model to calculate the calorie the food contains, and then we use the biometrics like heart rate, blood oxygen level to calculate the calorie consumption, and finally, our data is real-time and persistent, which is stored in the database. And finally is our profit point. So our app is closely related to the field like gym, restaurant, advertisement, and wearable industry. So when we cooperated with these kind of field, we can just earn some profits from these areas.
Let's ask to demo how collect the data and how it works.
Wearable pulse rate sensor. We do some like exercise to see what's happening in my pulse rate.
So we can see in our mobile phone, it shows the different pulse rate. Emphasize you have different activity levels.
Here is a section for collecting GPS data from mobile phone. So here the command line is using Termux location to get the location of the mobile phone, and then parse the result into the format like this. We can see the data contains data timestamp and longitude and longitude. And also our data include the pulse rate, which is collected from the pulse rate sensor, and finally we will use the photo of food that user upload from their mobile phone, and these are the data source for our project.
So for the pulse rate as a consumption part 1, so we basically use a JSON text from the sensor given data, and we give like calculate the consumption for the total different pulse rate, and we can see the total calorie burn as the value here. So we use Android phone as a GPS as a part of tool consumption. So we calculate the steps from the longitude and the latitude. It can be like commuting steps or walking steps, and we calculate the total distance and the calorie burn during that time.
So besides the GPS data and pulse rate data, we implemented a function that can upload a food picture, and we calculate the calories from the picture. So here's how we train the model. So firstly, we load the food data, and we do a pre-process for the dataset, and we now split the dataset into train and test set, and then we use the pre-trained VGG16 model for the data training. And here we use one layer, and which activation function is value, and a fully connection layer with the softmax activation. And here we use the ADAM optimizer and train the model for 100 epoch with batch size of 32. And now we save the model like this. And after training, and we use this Python file to load our dataset, load our model, and every time we start our app, we can load the model automatically, and we can cut the time needed to load the model every time.
And now we need to aggregate and store the data to ThinkSport. So here we successfully set up a ThinkSport using Docker, and we open a new device called mobile phone. And for demonstration, we use GPS data to show how the data is stored in the database. So here, to demonstrate, we use the a series of GPS data show here, and we use this Python file to upload the data to ThinkSport. So here we use the command. Now we can see the data is successfully collected here, which includes 3 attributes. And now, after implementing the calculator and model, we build a backend using Flask, and we expose some service like this, which provides some service for front end to display. So here we start the backend server, and we can see the model is loaded first, and then we can see the backend is started. So here we use Postman to test the backend. For example, we use the calorie today to get the total consumption and intake, and these service will use the calculator mentioned before. And also we use Folian to build up a map to demonstrate the entire commuting route daily. So here we use this URL to access the map. So here we can see the data is collected and displayed using Folian. And now let me show our front-end interface. So here first we need to start our backend server. And here we use Android Studio to build our front end. That is, we build an application for it. So here we run the device. So here the map, this graph is fetched from the backend, which present the calorie in a week. The blue line is calorie intake, and the red line is consumption. So the user can get their calorie balance based on this map, and the data below shows the calorie today. So the user can get the intake and consumption, and these data is fetched from backend. So here the user can upload a photo and upload it. So this photo will be delivered to the backend, and the backend will identify the ingredient and the calorie it contains, and the server will add this calorie to the intake of this user. So then we press return, so we can see the intake is added to 560 calorie. And another page shows the daily route for this user. So this map is also fetched from backend, and this map is generated by Folian. So here we can see the user's daily commuting route, and the data below is the total distance from today, and the total calorie consumption.
This is our final project. We want everyone to be able to join exercise and healthy eating, reach your goal program, sort the carb balance when you're exercising.